Simplify products and quotients of expressions with radicals. So here you have a product of radicals. Now there's a couple ways you can go with these things. You can simplify them separately and then multiply it together, or you can multiply the whole thing together and simplify it. So it's really kind of a choice, and you can try it both ways on different examples and see what happens. So I'm doing the 50 times 27, but I'm certainly not going to multiply those together because it's going to be a large number and it'll be harder to work with. So I'm going to keep it separate, and I'm using the radical simplification rule that the radical of products, these are all products, is a product of the radicals. And so then I have all these variables left here: x to the 7th, y to the 8th, x to the 4th, y to the 11th, and I grouped them so that the x's are together and the y's are together. Then I'm going to multiply those together. They have the same base. You add the exponents: x to the 11th, y to the 19th. Meanwhile, over here with the numbers, I'm looking for the biggest square inside 50, which is 5 squared is 25, and 25 goes in 50 twice. Again, over here, the biggest square inside 27 is 9. That's 3 squared, and that goes in there evenly. And so 9 times 3 is 27, so that's there. And now we're over here to the square root of these two. So you can think of it as it's a second root, square root. So 2 goes in 11, 5, remainder 1, right there. So x to the 10th times x is x to the 11th. Now you have your choice. You can write it this way like I wrote it, or you can just say x to the 10th right there. This could be 10. So x to the 10th times x. Similarly, 2 goes into 19, 9 times remainder 1. So this is y to the 9th squared, that's 18. Again, you can write this right here as y to the 18th times y. Then cleaning up these numbers, 15 is here. Square root of 2 times square root of 3 is square root of 6, and that doesn't come out of the radical evenly. And then over here, the square root of x to the 5th squared is x to the 5th. X is left. Square root of y to the 9th squared is y to the 9th. And this y stays in. So that's it. Okay, over here, just some numbers. And you can work on these separately. The biggest square that divides into 24 is 4. 2 squared, 3 squared is 9, it doesn't divide in. 4 squared is 16, that doesn't divide in. So it's 4 times 6. This one's 25 times 3. Similarly, square root of 4 is 2. Square root of 6 stays in there. Square root of 25 is 5. Square root of 3 stays in there. Then you multiply these together and you get 10 square root of 18. Then you realize that 18 can be simplified as 9 times 2. The biggest square inside 18 is 3 squared, which is 9, and square root of 9 is 3. The 2 stays in. 10 times 3 is 30. 30 square root of 2. Now in these numerical ones, you can run a calculator check, and that means just take the originals, you multiply them together, you get this. Take the answer, multiply them together, you get this. Checks out. It's right. Then go on to example 3 here. Again, I'm using that same method of multiplying the radicals together. Again, you have your choice of leaving them separate or multiplying them together. So I decided to multiply them together. I got the 54 is 27 times 2. The biggest cube inside 54 is 27, that's 3 cubed, with 27 into 54 is 2. And then I add these exponents. X to the 1st times x to the 11th is x to the 12th. y to the 5th times y to the 8th is y to the 13th. Okay, now I'm ready to simplify further. The cube root of 27 is 3. The cube root of x to the 12th is x to the 4th. Because again, you can view this as a 1/3 power. 1/3 times 12 is 4. Okay, with the 2 left in, and now you have the y of 13. I'm just playing it safe. I could have done the y on that step too, but I'm playing it safe. So I have y to the 13th. Now, there's two ways to go. The way I'm showing you is, alright, so I wrote out the alternate way to go here. See, my normal method that I was showing you was to divide 3 into 13. You get 4. So 4 times 3 is the 12 with remainder 1. And then you check it by saying y to the 4th to the 3rd is 12 plus 1 is 13, and it checks out. But you can go this way. You can go from this step over to here. You can say, just write the 12 there. 3 goes into 13 4 times, and remainder 1. So you see the y to the 12th as a perfect cube, and with 1 left over. So you can go this way. In other words, you don't have to write this mechanism right here. You can write this instead. Either way. Then you come down here, you already had this. Then the cube root of y to the 4th cubed is y to the 4th. And then what's left in there is the 2y. Okay? So there's a lot of ways to go. Just make sure every line is equal to the one above, and you got all these equals lined up. Then last example here, it's a quotient. It's a cube root, quotient of 2 cube roots. So I decided to simplify the variables by using the rule that the quotient of cube roots is the cube root of the quotient. So that's 104 divided by 13. X to the 5th divided by x to the squared is x to the 3rd. 5 minus 2 is 3. X to the 3rd divided by z to the 3rd divided by z is z squared. So now I'm here. Now I'm working on, there's a couple ways I could go. I decided to split off the number, cube root, keep that here. Cube root of x cubed is the x right there. And z squared is not enough to come out of the cube root yet. So you're here, now you're working on this 104. Sometimes the numbers are so big that you just got to prime factor it to see what the number is made up of. 2 goes into here, 52, 2 goes into there, 26, 2 goes into that, 13, 13, and 1. So I see a 2 cubed in there, which is 8. Okay, so 104 is 8 times 13, the 13 left over there. It happens to be coincidentally divided by 13. And you still have this stuff written down. Then you come down here. The 13 happen to cancel out, so you get the cube root of 8. You still write the stuff down. Cube root of 8 is 2. So the whole idea with these is to be careful and write everything down on a line and have everything lined up equal to the line above. Don't write anything off on the side of the paper except for maybe something like this, to where you have parts of it floating around. Then you're going to make a mistake.